Good morning, everyone. Welcome and thank you for joining us for Teledyne ISCO's January webinar. Today's webinar is being led by Nick Daddabbo, our Pumps Product Line Manager. And our webinar is focused on selecting the right pump type for your application. So at this time, we will throw it over to Nick. If you have any questions or comments throughout the webinar, please utilize either the chat function or the Q&A function within the platform, and all questions will be answered at the end. We'll give Nick just a quick second to get set up here.
Good morning, everybody. Can you hear me now?
We can hear you.
Perfect. Okay. Well, good morning, everybody. Thank you for attending the webinar this morning. I know we all have busy lives in the very beginning of January, so I appreciate you taking the time to listen to us speak about selecting the right pump for your application. So a little introduction. My name is Nick Daddabbo. I am the product line manager over our pumps business here at Teledyne ISCO. I've been in product line management for now, I'd say 18 plus years with a few different companies, very, very heavily pump focused companies, so Xylem, Gould's Pumps, IDEX, XPX. And a lot of the markets I've dealt with in the past have been oil and gas, pharmaceuticals, chemicals, food and beverage, and just specialty pumps also. So without further ado, let's kind of get into the meat of our presentation. First off, what I want to do is I want to define the world of pumps. Let's talk about the world of pumps. And here we have here is a chart that is from a reputable source that really breaks out what pumps the world is. And you can see there are very, very many different types of pumps out there, including on the left there, you'll see there's two major types of pumps. There's centrifugal pumps, so pumps that are move and rotate, and then there's positive displacement pumps, and then there's a small slice of other types of pumps. And then you look at the world, even just breaking a little farther, you're looking at the world of positive displacement pumps, and you look at all the different variations you have there. You know, you have gear pumps, you have diaphragm, you have peristaltic, you have piston and plunger, you have screw, you have vane, you have lobe. And even within some of those classifications, you have other types of pumps. So when you talk about the world of pumps, there is many, many, many variations within the categorization of pumps. Two major types of pump types are positive displacement, which basically physically draw fluid into the pump at an inlet and then force it out of the pump outlet. So there's many different ways we do that, and we'll talk about the different types of those pumps. But they would be more like your diaphragm, your reciprocating, even in some cases peristaltic. Those would be your positive displacement pumps. And then rotodynamic is, as I said earlier, it uses a rotating impeller or a rotating mechanism to draw a vacuum into the inlet side of the pump and send the fluid out at a higher pressure to the outlet. And typically you see these applications in these applications in larger factories, oil and gas, or water treatment facilities, where you need to move high volumes of fluid. You know, there are your smaller volumes of fluid, centrifugal type pumps, but for the most part, these are going to be doing gallons per minute, hundreds of gallons per minute at pressures that are 1,200, 1,800, 2,000 PSI. And they're going to rotate, they're going to have an electric motor on them that rotate them, 1,750, 3,500 RPMs a minute. So you've got some pretty fast moving pumps. Today, we're going to focus on just the positive displacement type pumps. And different types of those, and what to consider when you're looking at applications. So that's just a kind of a pump primer, so to speak. I guess there's a pun there. I didn't mean to do that. But let's move on to positive displacement pump technology. So we're going to talk a bit about the different types of technologies that are out there in the positive displacement world. So first and foremost, you have syringe pump technology. And, this is very simple. everybody's kind of gotten their flu shot or allergy shot. You draw back the cylinder, push the fluid back out. That's a very basic concept of syringe pump technology. Some of the advantages, it's a long-lasting design. This design has existed for years, and it's very precise. That's the key thing to think about. When you need something that's really precise, you need a very, very low flow or very, very measured dosing of some type of a chemical reagent, fluid, colorant, whatever. This is something that really should come to your mind and trigger right away. You can get the higher pressures. I've seen 30,000 PSI out there. We have a 30,000 PSI pump. You can get to 40,000, excuse me. And it is a pulseless design. So when you need, it goes right along with precision. When you need kind of a very steady, no blip flow, you're going to look at a syringe pump. Disadvantages, honestly, it's the higher cost of acquisition versus some of your other pump technologies. So one of the things you want to consider when you're looking at your application, and we'll hit on these as we go along, is what is the trade-off? What's more important is the precision and the smoothness of what you're moving or what you're inputting into another area, like if you're pumping a reagent in for a reaction chemistry experiment, or if you're dosing a colorant into a plastic making application or something else. If precision and pulseless flow are important to you, then the trade-off is you're going to have to pay a higher cost of acquisition for it. Versus if a cost of acquisition is important to you and you can sacrifice some of the precision and pulsation, then you're going to want to look at other you can look at other types of pump technology. This would be kind of the Cadillac of the applications or types of pumps you would use for moving flow or moving materials. So as I look here before, any application that is basically where precise dose is required, I've referenced reaction chemistry. That is definitely a very solid application for this type of pump. When you're considering moving specific sizes or amounts of reagents or chemicals into a reactor, this would be very helpful. Moving down to, let's look at the next type of pump technology. Some people call these piston pumps. We call them reciprocating pumps. It's kind of like a train engine. If you think about the wheel turning and the bar that's moving the wheel back and forth, that's really what this design is. Backward forward motion to move a fluid, pulls it in, pushes it out. We talked about that earlier. You can see from the diagrams here, very, very simple design. It's tried and true. It's been around for a long time. The interesting thing about the designs of these positive displacement pumps and their technologies, it's very rudimentary, very basic when it goes down to the core. The pump themselves add the features or the outlets and inlets and the check valves, all that stuff. But the true, how does it work is very, very simple. Some of the advantages, you can get a higher pressure, lower flow. And like I said, this is a very proven design. It's been around for a while. Again, how long have trains been around? It kind of does the same type of movement, right? Disadvantages for this, and this is something to really keep in mind, is, when you're looking at your application, if your fluid is very viscous, kind of more on the molasses type of a viscosity, this is going to be a tough type of technology to use. You're going to struggle. The pump will struggle because most of these designs have check valves in them, and check valves do tend to get gummed up sometimes with viscous material. So, that's keep in mind. You need to consider that when you're designing your application. It's not a pulseless flow. You can take out the pulsation as much as possible by adding in a pulse dampener, but it's not going to be to the pulseless level of the syringe pump. Now, this goes back to what we said earlier. What's more important to you? If you can sacrifice some of the concerns about pulsation, add a pulse dampener to this type of technology, and then you say, okay, well, it's not completely pulseless, but it works for me, then you can save a few dollars. This is a lower cost of acquisition than your syringe pump comparatively. But it does get pretty close when you add the pulse dampener in and the different feature sets. So you want to monitor that and look at that. Look at that in your choice. as everybody looks at their budgeting dollars. So I know that's going to be a consideration. The applications, wherever you need a steadier, lower flow. Looks like my train engine kind of overbled into my words there. But, you know, HPLC, dosing, colors, just moving fluid. We do have a pump called the Reaxis that can also just provide constant pressure, not necessarily constant flow, but constant pressure alone. So if you need something to just provide pressure so it'll help something move along, you can definitely do that, use that. Okay. So the third type of technology here is a peristaltic pump. Now this is one, it's a very interesting, this is kind of like the happy medium between, this is kind of a nice option to a reciprocating pump. You know, first off, there's no wetted parts. The fluid stays in the hose. So the only thing you have to worry about is changing the hose or the life and the degradation of the hose over time. So there's low contamination risk unless the hose bursts, but you're going to see that and know that versus it leaking inside the unit or something like that. For those that are dealing with pharmaceuticals or food operations, you know, there is sanitary hoses that are available for an actually, you know, higher cost, but they're available for use in a peristaltic, so it meets FDA standards, etc. Easy maintenance. You can typically change the hose on most peristaltic pumps in less than a half hour, and you typically won't need a full technician to do that. You can do it yourself, or you know, have one of your workers do it for you. That's a benefit. Disadvantage, you know, I talked about hose life. Hose life can vary depending on how much you use it, how hard it runs, and the viscosity and or temperature of the material that goes through it. So you need to put those into consideration. Say, if you're looking at an application that's going to have a high temperature type of fluid going through, and it's kind of somewhat viscous, you're going to stress the life of the hose just a little bit. So, you know, you want to consider that when you're setting up your application and looking at which type of a pump I really need to use. You know, really, this can be used to move. This is a great general purpose pump technology. It can just move fluid. If you all you're worried about is moving fluid or pumping something into a reactor or into a tank or something of that sort, this is a nice little pump. They're typically smaller footprints, so they can be sit somewhere anywhere. They can be stacked on top of each other. You can have 4 or 5 running at different times. You know, but you're not going to get the performance, the precision of the dosing of a syringe pump. You're going to have better application for viscous material than you would over a reciprocating pump. But some of the pressures and flows that you can get out of a reciprocating pump, you cannot get out of a peristaltic pump. So that's the other thing too. If you require a higher level of pressure, you're going to want to move. You're going to want to stay with a reciprocating pump versus a peristaltic pump. Okay. But anytime you're thinking about super viscous fluid or viscous fluid, you want to be looking at this type of pump technology versus the other two we previously mentioned. Looking ahead, another type of positive displacement pump. You got gear pump technology. So this is just very simple. It's just 2 wheels, 2 gears moving and pulling fluid in, pushing it out. And it's, you know, it's good with viscous fluids, but if there's particulates in the fluid, that's going to wear away the metal or the plastic on the gears. So, you know, look at you again, this goes back to when you're designing the application, look at the fluid that you're using, look at how fast it's going to move, look at the viscosity of it, and you can kind of pick and piece which types of these technologies you would want to be able to use. You know, it's something that I see all the time with this pump. It's more in a wastewater application, but it doses hypochlorite into wastewater for sanitization purposes. But you can kind of use it to move fluid pretty much in most places. You know, it's not a very precision flow. It's just moving flow. Now, the good thing about this is bidirectional. So if you need to suck something back out of the tank you just put it into, you can get it to do that. You know, it's very generic. You can change the gears in some of the pumps. I know there's a company out there that you can literally change the gears of the pump in less than 5 minutes. So that's a nice piece. But these, from a price standpoint, they're going to be they'll be more than a peristaltic and right about the average or a little less than average than the reciprocating pump. So consider this here. You don't see a lot of these in pharmaceutical applications or chemical applications. Well, you do see some chemical applications, but pharmaceutical applications, you don't see a lot of them. Last one here we'll talk about is the diaphragm pump technology. You know, this is one here. It's a simple bladder, like a moving back and forth, pushing and pulling, and the piston never really touches the fluid. It's just the bladder that does. It's less expensive over time, doesn't require a lot of maintenance. The bladder, the diaphragm or the bladder typically doesn't wear out as easy, depending on the material it has. You know, low risk of leakage. I can tell you though that, you know, they have check valves that, again, the problem that reciprocating pump have. So if you have viscous fluid, they could get gummed up or sticky. The diaphragms do struggle with particulates. The particulates will wear down the diaphragms themselves and shorten the life of a diaphragm. Changing the diaphragm in a pump is a little bit more arduous to do than it would be for the peristaltic hoses and potentially the gears and the gear pumps. You know, if you need to, and where I see these a lot and where you should see these a lot is moving a lot high volumes of fluid. Not to the levels of a centrifugal pump, but definitely to the levels of, you know, a reciprocating pump or higher. You're going to move, these will probably be gallons per minute because this is a fast moving, it's very high volume internal to the pump. Okay, so you kind of look at just over an overview here. You've got just a quick little chart that shows, you know, your costs, some of your advantages, disadvantages. Very easy. We just talked about all this here, but this kind of puts it all together in one slide. You know, in today's day and age and tight budgets, you know, cost is a factor. So you have to weigh out when you're designing your application, what's the trade-off? You know, am I worried about how much I'm going to pay? And, you know, if I am, can I sacrifice the ideal performance for something a little lesser? Or am I worried about performance and I need the best possible performance I can get? Well, okay. Then you know you're going to have to probably have a higher cost of acquisition. So let's look at some questions that you might ask, as you should ask or consider when you're setting up or designing your application. Okay, and this poor guy here, there's all kinds of things going on in that picture there, and you know there are many variations, not just of the types of pumps, because you saw that earlier in the chart, but you can look even within the type of technology. There's variations inside of those too, which is pretty interesting actually. So let's keep going here. So, you know, like I said, you want to look at what is the goal of the setup. Are you moving fluid? Are you trying to get precise mixture? Or do you need both? Do you need just pressure to create or have something happen? You know, that's the first thing. You understand what that goal is of the setup and the application, whether it's a pilot plan or lab scale, et cetera. And then we've talked about this, what is more important, the success of the project, meaning the performance of the pump to help create what you're trying to do in the end run, or is staying within budget? Now, everybody's going to say staying within budget's important, but as we talked about, sometimes there may be trade-offs you have to make. You either have to accept you have to pay a little more, or you can say, okay, I can't pay that much, so I need something a little lower performance. Obviously, what is your budget? Everybody, that's the first thing everybody knows, right? And then what vendors? I mean, who understand out there who provides what? Who provides what type of pumping technology? Who provides what type of application assistance? Who has been in the industry for a long time? You know, who has the ratings on the products, et cetera? You know, those are very, you know, and what are you looking for in a vendor? Are you looking for just somebody, okay, I need to order to ship it to me and I'm done with you? Or are you looking for somebody that wants to help you understand, or wants to understand your application and kind of help you find the best setup for you, not just for your price, but also for your application? Those are two different things. You know, then what is the timeline for your purchase? I mean, that's, you know, what is the time? Is it going to be 6 months? Is it going to be 3 months? Is it going to be 12 months? And then what types of pumps are you looking for? You know, what types of technology, et cetera. Okay, those are things you want to kind of consider when you're looking at, you're starting setting up the application. You know, that's going to be something that, you know, there's probably a whole list of questions you go when you start to set up the application or set up your selection process, but these are some key things you want to keep in mind. And then you want to look at the other types of installation questions. You know, what type of process is the pump being installed into? Is it a desktop? Is it a laptop? Excuse me, a lab scale where it's sitting at the top of a in a fume hood? Is it sitting on a counter, or is it in a pilot plant that's kind of a small setup? or is it in scale up, or is it in production? I mean, some facilities use these type of pumps in full production. So you want to understand that, because that's going to give you an idea of the type of pumping technology you want to need. And honestly, you could use a different pump from lab to scale to production, or you can use the same type of pumping technology. So you want to consider that. And I would say always look to the future of what you're going to do after this application is successful. You know, how much room do you have available? Do you have horizontal room? Do you have dimension? You know, what are your dimensions? Because that's going to tell you. I mean, we talked about Peristaltic has a small footprint, but you know, syringe pumps sometimes are pretty tall. So you want to consider that. And okay, so is there things you have to consider? Is the fluid being pumped aggressive or corrosive? Then that's going to narrow down the type of pump, or at least the feature set you're going to need on the pump, right? And does the fluid need to be heated, cooled, or maintained? That's again another feature addition to some pumps, and some pumps can't do that. They can't handle the heated temperature. You really, really need to kind of, you know, put all these pieces of the puzzle out first, and then do like a columns of checkboxes to say this technology can do this, this company has this, etc. I'm sure a lot of you do that, but I just want to kind of keep that in the foremind. Another one here, does your fluid have particulates? We talked about how particulates can damage different types of pumping technology, or at least impact their performance. What's the viscosity of your fluid? We go back to, you know, that'll narrow down the technologies you can use. If it's a hazardous area installation, what's the classification of the area, and what's the classification of the adjoining area? Is it something maybe that, like if it's a syringe pump, do you need to put the controller in a non-hazardous, and then the syringe will sit, you know, through the wall into the hazardous area? Many different ways things you need to consider there. And is there a long distance to cover from the pump to where it's going to be controlled? I mean, do you need an extension? Is it going to be able on board? Can you handle that? You know, this is all stuff you should know from where it's going to be installed. And that all of these influence the pumping type and the technology you're going to use. So sometimes there's other special considerations you need to look at, okay? And we're going to kind of go through a few of them here. First off, you know, do you need continuous flow? You know, is it something that you need? So that'll tell you if you need one pump, or if you need a pump with two heads on it, which you're not going to find that in gear pumps. You won't find that in diaphragm unless you use two pumps connected together, which is difficult. You know, Peristaltic, same thing. You're not going to find that. So you're going to narrow yourself down to reciprocating pumps and potentially syringe pumps. You know, you could do it for the other types of pumps, but you got to make sure they're connected together. You can see a picture here where we have one controller and 4 syringe pumps being controlled by one controller, and there are 2 continuous flow systems. So, you know, those are things you need to consider in your application, and how you set it up. That's one thing that you need to look at. Another one we just talked about is space constraints. You know, is your lab, where you're going to be, is it tight on space? You know, then that tells you the different types of pumps you can use or sizes you can use. Okay, and you know, that's something that you know, you have to consider. And you also want to be able to, you know, adjust your application or adjust your positioning in the space itself. Now we have short pumps or smaller types of short pumps available, but you can use your peristaltic pumps, or some of your gear pumps are smaller. So you want to look at that. You can also mount the pump or syringe pumps upside down or horizontally. So sometimes your pumps can function that way. High viscosity, like I said, the materials being pumped is viscous, you know, so that's an issue that you want to make sure that the pumping technology you use can do that, but also, you know, even can handle up to super really thick stuff like pasty type stuff. You know, I know with some of there's other ways you can do it. You can put heated jackets on the pumping heads, or you can, you know, kind of change the viscosity of fluid as it goes in, or you can use a wider ports, etc., on like syringe pumps and or different types of pumps. corrosive materials. I had said earlier that you need to be considerate of that. There's different material types that are out there. I know reciprocating pumps have different types available, Hastelloy, titanium, or PEEK. Syringe pumps can have different type of material. I know gear pumps and diaphragm pumps also do that. For the peristaltic pump, we talked about the hose types and the chemical makeup of the hoses. So I think that's going to be, those are things you always want to be considerate of. Please, 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 when you've got corrosive materials, make sure you check the corrosion chart, a corrosive chart for compatibility of the material you're going to be pumping through. Now, last thing you want to do is find out, and after you set the application up, that, oh darn, this doesn't work with this material, or it's too corrosive for it. And then fluid structure, sometimes you need to add something in to keep the fluid moving. From a syringe pump standpoint, you can put a mixer in to keep things in suspension or keep the particulates moving. But other types of pumps, it might not be as easy to do. You have to maybe run it through a pressure pot and then back into something else. There's different things you have to do. So consider the fluid structure when you're trying to set up your application and what you need to do in the meantime. Other potential challenges, we talked about, where is it going to be controlled from? Some pumps out there have controllers right on board that are finger touch. Some connect back to a PLC. Some have a separate controller that you want to pull away from there. Excuse me. So you want to consider that as far as when you're looking at your setup and how your application is going to work. And then mounting the pump in a hazardous area. We use a lot of our applications out there have hazardous location ratings, and you want to make sure that the pumping that you use can also handle the hazardous location area with no arcing and sparking. Sometimes that's a challenge when you're trying to, it's some of your class 1 div 1 areas. It's very hard to find a pump that'll work there that might be in this application. So you have to maybe consider putting it in a box, a NEMA 4X box or an explosive proof box to have it run in there to protect against arcing and sparking. These are things you need to consider when you're looking at that. So with that, there are additional resources available on the web. You can go to our website. We have a bunch of technical bulletins and application notes out there that will give you information and might actually have handled some of the questions or applications you've tried to in the past. Google Scholar is an amazing resource for academic research using pumps. You can find all kinds of things out there to see how other people used it or what type of chemicals they were able to use it for. And then, be honest with you, we also have hundreds of years of engineering application development experience within our organization, so we're always available to answer your questions or try to help out wherever we can. With that, folks, I've come to the end of the presentation. I want to see if any of you had any questions.
And at this time, as we wait for questions to come in, just a reminder to use either the Q&A function or the chat function within the Zoom platform, and we will answer those questions. I do want to let you know that our February pumps webinar will be taking place on February 13th, and that will have a focus on Pumping 101, what to consider. So be on the lookout for more information coming through about that upcoming webinar. Also, after the webinar, we do have just a short survey to help us improve our webinars on a monthly basis and get any feedback from you guys. So you will be receiving information to provide us with feedback on how today went. At this time, Nick, we've had one question come in, and that is, what pump would you recommend with a flashing fluid at low flow rates?
Say that one more time.
What pump would you recommend with a flashing fluid at low flow rates?
Okay. Dale Clay, are you on the line?
Yeah, I'm here. I can throw in a couple things. If you're having pumping fluids that flash, the key thing is on the refill side, going to a vapor. Our pumps do very well. The syringe pumps, you can slow down the flow rate, for example, to give it more time, the fluid to keep it in the liquid state. We also have temperature control jackets, which will cool the fluid down and also tend to keep it in the liquid state. So there really isn't any problem. Once you have it filled in the pump, then as far as delivery, there's no issue. It's mainly on the refill side.
Thank you, Dale. Are there any other questions out there?
We'll give it a few more minutes to see if any come through. Nick, and I don't know if you have any frequently asked questions that you typically get that weren't hit on during the presentation that you wanted to touch on here at this time as well.
Actually, I do have one, and it's kind of a generic one where, you know, what I've been asked in the past is, you know, do you have to have one type of pumping technology throughout the whole application, or, you know, are there cases where you can have 4 or 5 different things, the types of pumps being used? And that is the case. I've heard of applications where, you know, when you're setting up reaction chemistry, you know, you have a very high potential or high pot type of reagent that you only want to dose at a low rate, so they'll use a syringe pump for that, and then they want a different reactant to pump in at a higher rate to cause those two to do something different together to come out to a third type of a chemical makeup. And people would use a peristaltic pump there. I've heard of applications where people have used a syringe pump, a reciprocating pump, and 6 peristaltic pumps in one application. So it is good to mix and match. You know, the things I would caution there is make sure you're clear with, when you set up the application, that the right fluid's going the right way, the hoses are going to the right pump, and everything is just all very, very segregated out to each piece, to each pump correctly and very clearly. So there's no confusion, no mistake. And if something goes wrong, you know exactly which pump to turn off right away or fix.
Great. And as we wait to see if any other further questions come in, I do also want to let everyone know that this webinar today is being recorded. So this will be available on Teledyne ISCO's YouTube channel later on this week, and will also be sent out as a link to all of today's registrants and attendees. Okay, well, I'm not seeing any other questions come in. If you do have any follow-up questions, our contact information, you can find that through the Zoom platform. Nick, I want to thank you today for walking us through this presentation, and I want to thank everybody for joining us as well.
Yes, I thank everybody for taking the time out. I hope you found it at least a little informative. And if you have any further questions, feel free to reach out to myself or anybody else on our Teledyne ISCO team, and we will be very glad to help you out with that.
Great. Thank you, everyone, and have a great day.
Yes. Thank you.